Welcome to another lecture of our prologue playlist. Today we are going to learn something different. From the second lecture almost, we are doing programs and traversing lists with help of recursion. But today we are going to learn about another method without recursion's help. We are going to find the length of the list. So how do we do that? We are going to use accumulator. Here list len is going to be our main function, which we will be calling from our output terminal, and here we are having a list input, that is L, and output, that is the length of the list, that is N. Okay, and this will call another function inside our program, that is len acc. So this acc means accumulator. Here I have named it to look familiar. So the length accumulator function will have three parameters. Okay, so L is the list which we already have, and N is the output which we are going to give. But here we are having another middle parameter, it is an initialized with 0. So this is the length of the list which we are counting one by one in our every traversal, you can say. Here we are going to have our recurring functions here. So it will have a list inside it as an input, and A is here the accumulator, which is the length currently of the inside the accumulator stored, and N is going to be output, and we are increasing the value of the length with 1, that is A1 is A plus 1. Okay, so A1 is becoming A plus 1, and then this A1 is going inside the recurring function call. Okay, so we are first incrementing the value, then we are sending it to the recursion call. Okay, so that is the point to be noted here, because in the recursion part we were calling the recurring function first, then we are incrementing it, but now we are first incrementing it value. For that we need to initialize it with 0, that we have done in the first line. Okay, so we are first getting the length incremented, and after that we are calling the recurring function here. Okay, and after that we are calling the recurring function call. So remember this very carefully. So we, as obviously we are splitting the list in H and T, and we are for the H element, that is one element, so we are incrementing length with 1, and we are again recurringly calling our function for the tail part, that is the rest of the list. Okay, so but we also going to need a base condition here. So let's see with an example how to do that. So suppose the length of the list is 1, 3, 5 and 7. Now what is done first the value of A1 is incremented. So for now value of A1 is 1, and now the recursion call is made for the rest of the list, that is 3, 5 and 7, and also it will be having other two parameters, that is N, that is the output, and also A1. So here value of A1, that is 1, will be going to pass in the len AC recurring function call. Now again for the next run, the A1 again be going to be incremented. So it was 1, and now it is going to be incremented with 1, and it will become 2. Okay, so the now the length becomes 2. So in this way, with all the elements we are traversing, the length is being incremented first, and then the recurring function call is being made for the tail part. So that's how we are incrementing it one by one, and at last we are going to have our base condition. So as you see, we are in a moment where we are having an empty list. So our base condition should be for the empty list. Okay, so if the list is empty, then we are just returning the value stored in the accumulator as our output. So if the list becomes empty, then we have traversed all the elements, and we have counted all their length, and we have incremented the accumulator's value with 1 for all of the elements, and now we are returning that value to our main function, that is the list len function. Okay, so now we have already calculated the value. So let's see for this last function call, the accumulator's value becomes 4, and it will be returned. Okay, so let's run it and check. So we are running it with the same sample input we have explained inside our code. So let's call it and see, our output is showing us 4, so that means we are correct. We are going to run it again with another set of input. We are just adding another value inside our list, and it is incrementing our length with 1. So now let's move towards our next structure. So I have already told you that one of the structures inside our prologue is list, and another type of this structure is a tree. So you can see from the first part, that is I have drawn a tree here which root node is 30 and have both left child and right child there. So how do we write this type of tree? So to declare a tree structure inside our prologue code, we need to write the tree keyword, and inside that we are having three parameters. Okay, so the first one will be the root node, and the second one will be the left child, and right one will be right child. So here in the left child there is also we are having another tree. So we are already calling tree again, and for the left child the root will be 25, and again with another tree, that is its root is 10, and left and right will be void. So see, left and right will be void means there is no left and right child for it. Okay, also for 25 there is no right child, so instead of right child we have written void. So that's it. That's how we write a tree. You can already also see yourself that the right child of 30 is 60 and the left child of 30 is void. So that's how we write a tree. Now we are going to do some famous traversals, that is tree traversals algorithms. So we are going to have in order, pre-order and post order. So let's check for in order. So what is the situations for in order? For in order the order remains same, that is the left child is called first, then the root, then the right child. So that's why we are just passing two parameters inside our in order function, that is a tree. XLR, X is the root, L is the left element, and R is the right element. It can also be a trees also. Okay, and Y is our output. Okay, so Y is going to be our output. So Y is going to be a single node. This is not going to be a tree. We are going to have every node at a time, and this will becomes what? This will again call the in order function recursively for the left child. Okay, so for how many times the left child will be called? For the left child this in order function will be called until it reaches a leaf node. So when we will understand that it reached a leaf node, so look for the second function where tree have only root node and both left and right childs are void. So this void means that this underscore means void here. Okay, this means this have no left or right child. So only then we are returning the value of the root node itself. Okay, so then this value of the root node will be printed, and after that we are calling the same in order function for the right child or the right subtree of our part. So now this is done for in order. Now just for pre-order we are just going to change the order of these statements. We are for pre-order, what happens for pre-order? We are having the root node first. So I have written the root nodes statement first, that is for the if it both childs are void, then print it. And after that we have what? After that we have our left subtree, and then we have our right subtree. So this is the order of pre-order. Now for post order we have our left child and right child first, then we at the end we are having our root. So that's the post orders arrangement. So I have written our code for both in order, pre-order and post order traversals, and now it's time to run it and check if we are going correct or not. So see, we have already written our tree here. So for the in order we are running it now. So for in order we are having a variable in order that will be going to give us the elements in the perfect order which we are asking it. So first the in order, the left subtree is printed. So 10, 25, 30, this will be our left subtree order, and the right subtree will be 60 and 70. Okay, now we are going to do it for pre-order. So first for pre-order, first the root will be printed, that is 30. Here in our case it is 30. Okay, so first the root will be printed, then the left subtree, then the right subtree. So see, first the root is printed, then it is doing in the pre-order manner. Now for post order it is going to print the root at the last. Okay, so first it is going to print the value of the leftmost child, I guess. So see, let's check and run it and check. Okay, the root will be printed at the last. That's what we know for post order. Okay, so now let's run it and see. So see, as we have already told, the root 30 is printed at the end. So that's it for our prologue lectures. Now if we need any other video, then comment and do subscribe.